You're listening to video 2 of the 6364 lesson for Calc AB. And we're now going to look at the quotient rule. We start with this idea. Suppose we have two natural logs and we're subtracting them. And I hope you're getting old hat at this now, that we could take this expression and we could rewrite it using inverse operations. So natural log of A minus natural log of B becomes our exponent. E becomes our base, but that changes the value, so we need to take the whole thing, the natural log of. So, the first thing I'm going to do is note that this minus is really a -1 and there's an addition right here. And so we've got this -1 as a coefficient to the b. And if we wanted to, we could stick that right into the exponent using the power rule of logarithms. So let's rewrite this as natural log of e to the natural log a plus natural log b to the -1. And then since we've got addition right here, and this is an exponent, we can rewrite it as the natural log of e, natural log of a, times e to the natural log of b to the -1 is 1 over b. Can you see where the quotient rule is about to come from here? So we know what this is equal to, that's just a. We know what this is, that's just 1 over b. Therefore, we get natural log of, this is a, 1 over b is like dividing by b. So this came here, and this came here. And so, of course, any time that we have two natural logs being subtracted, we can think of that as the natural log of their quotient. Okay, so now let's look at an example where this property is going to be helpful to us. I want you to find f prime of 2. Where f is a function that is defined as the natural log of x divided by 1 minus x, the quantity squared. And so I think you can see pretty quickly that if we tried to do this one straightforwardly, we'd really be in trouble, because the first step would be 1 over this thing that's inside the integral. So we'd already have a fraction within a fraction, and then you would have to use the quotient rule to take the derivative of the inner function. So instead, what we're going to do is we're going to start by rewriting, just like we have on all the rest of the problems. So f of x is equal to, I'm going to take that 2 and pull it in front, so we get a 2 right here. And then I'm going to use the quotient rule to disassemble this so that it's 2 natural log of x minus, because it's quotient rule, 2 natural log of 1 minus x. So that's our rewrite. Now we can take the derivative. And our derivative in this case will be f prime of x is equal to, the 2 is along for the ride, times 1 over x is the derivative of natural log of x, minus 2 times the derivative of natural log of 1 minus x would be 1 over 1 minus x. But don't stop there, we're missing something. Think about what the derivative of the inner function is. Since it's 1 minus x, x has a coefficient of -1, and we get this. All right, so let's note that those two negatives are going to cancel. And so the last step in this case is going to be, since we want to know the derivative at 2, let's plug in that 2. When we do that, we get f prime of 2 is equal to 2 times 1 over 2 plus this would be 2 times, that's a 1, plus this would be a 2 over negative 1 would be a negative 2, gives us a negative 1. Hey, we're in the home stretch here. We have one more property to look at. Proving this one's going to be a little bit different. This is the change of base. So let's start with an unnatural base. I'm going to call that base b. So we've got the log base b of x, and we want to know what else that could be equal to. So I'm going to call it question mark. Well, keep in mind that this is just a fancy way of saying b to the question mark power is equal to x. So let's rewrite it that way. Well, if b to the question mark power of is equal to x, then the natural log of this side should be equal to the natural log of this side. And now do you see anything that we could do with that question mark? Keep in mind, we want to figure out what this is equal to. We're not going to figure it out while it's in the exponent. So let's move it in front. We get question mark times natural log of b is the natural log of x. And we want to know what question mark is, so let's divide. And we end up here with question mark being equal to the natural log of x over the natural log of the base. So the moral of the story is, let's come back up here, log base b of x is equal to natural log of x over natural log of b. With that in mind, let's look at one last example where we're going to use this property. Suppose we want an integral this time. We want the integral of the log base 9 of x divided by x dx. Ugh. Okay. Step 1, let's deal with this mess. When we see log base 9 of x, we think, oh, that's really just natural log of x over natural log of 9. There's a function, there's a number. Now there is this x in the denominator here, and so I'm going to take that and write that over here as 1 over x dx. And then this natural log of x is, natural log of 9, that's confusing me. So I'm going to pull that out. And now we have a situation where we can do a u sub. If we were to say that u is equal to the natural log of x, well, that has a very convenient du. Look at what du would be in this case. 1 over x multiplied by dx, or in other words, this. So what we're really looking at here is u times du. In fact, I'm going to go ahead and rewrite it that way. So u is a linear function. Its degree is 1. When we take the antiderivative, we would get 1/2 of u squared plus the kitty. And so our final answer here is going to be 1 over, let's move that 2 in front, 2 natural log of 9 times u is really natural log of x, the quantity squared, plus c. I want to address one issue with you that might come up, and that's this 2 right here. Sometimes I've noticed that students want to take that 2 and move it in front because it looks kind of like the power rule, but you can't. And the reason is that the power rule only refers to when the exponent is on the x, and this exponent is on the entire natural log of x. Okay, so with that in mind, I want you to get out your book, and I want you to turn to section 6.3, and in 6.3 you're going to do numbers 15 through 26, all. And when you're done with those, you're going to go to 6.4, and in 6.4 you're going to do, hang on, I'll be back in just a second. Number 2, that one is a word problem, and then 6 through 32, the evens.